Thanks for having me this morning, everyone. I was just thinking about this as an event as kind of what brings the community together. I just think it's so cool the way that we have a community in our industry where we can do these types of things on a weekend. People volunteering to organise these types of events is just pretty unique across many industries. And I was actually chatting to, part of the reason Adam's taking a photo here, I was chatting to him before. It was about, we worked out 14 years ago now, I did my first user group presentation that Adam pushed me into a little bit. Hey guys, off you go, Tatham, it's time to do a user group presentation. And that was about unit testing. It was very, very basics of unit testing, 101. Did I know a lot? No. But did I have something to share? Sure, I had some of my own experiences. And participating in that type of community is a really big part of what's driven a lot of my career. So highly encourage everyone to not just come along to these things, but also actively participate and get involved. It's been quite a ride. Thinking about all that, the reason that we're here today is really to learn about what's next and to get better at what we do so that we can improve our careers, right? And that's what I want to talk about. There's a lot of different things that are coming, and we can get wild and crazy and talk about programmable genetics and DNA as storage and saving the whole human race and whatever else that Elon Musk is working on this week. But I want to start and try to keep it reasonably focused on stuff that's kind of now or near future, stuff that's reasonably identifiable and tangible that we can kind of see, yep, that makes sense to us. And then really look at the connections between them. So how do bots relate to mesh Wi-Fi? Or how do Greek swimming pools relate to quantum computing? That's what I want to explore through today. As Dave mentioned, Tatham Oddie, I'm the Managing Director at Redify, which means I get a really privileged position to look across kind of the future of where we put our investments and everything that our people have fun working on and try to stitch that together. So today is a bit of my own thinking of how do these items relate to each other. It's just one opinion. I'd love for you to tell me where it's wrong or I missed something or where you have a different idea and keep that conversation going. But I do want to make today quite actionable of stuff that we can actually go away and learn. So we've got to start pulling the thread somewhere. Let's start at interface. Now, interface is something that we've done a really good job of in our community. It's why we've trained people out of long forms news articles. We've managed to fill it with every bit of ad there is, take up all of that extra space. But it's driven great innovation around ad blockers at least. So this obviously hit a little bit of a note with some people. Have very quickly got 29,000 likes. How do we start to pull this apart and look at interface in a different way? Well, the big obvious one that's starting to come up a lot is the concept of bots. Now, this is the ABC News bot. How many people use this already or are aware of it? Not many. All right. This is a messenger bot. You can go and add it as a contact, and it will send you breaking news alerts. It'll send you regular kind of news every morning. So I get it sends me a message at 6:30 a.m. every morning and says, here's the top headlines of the day. And it gives me a really simple interface to go and drill in to say, tell me more about that story, or no, give me the next story, or move on through. It has alerts because it has push notifications. It has a dynamic view of time without me having to go and adjust the app. So when I fly to places that don't seem to understand daylight savings, it automatically moves an hour because Facebook knows that I moved every time I sign in, and it tells the bots, and off it goes. So it works with that. It works across my phone and my laptop. It gives me a multi-device experience. It's a familiar user interface that I already use, and it's another app that I don't have to install. And it can go and break out to the web if I need to. So let's park the bot bit though. I want to initially focus on this idea of the conversational interface that sits behind this and how people come and interact with this kind of more text-based medium, predominantly text-based. Now, my reaction to most things on mobile at the moment is I'm kind of right on the edge of that millennial sort of age group. And I sit there and think, actually, I don't really want to do most stuff on mobile. I hate booking flights on mobile. I hate doing internet banking on mobile. Sit there and go, just give me a real computer and a real screen. But why do we end up kind of collapsing down to these smaller and smaller interfaces? Now, one answer is access. So there's an awesome Australian, Ben Schwartz. He has a startup called Calibre app. Calibre app's a web performance monitoring tool. He just hit a big milestone this week. He's about a year in. He's just gone profitable. So we have another Australian profitable service, which is awesome. But he did a bit of research late last year around the amount of hours that you have to work at minimum wage in different countries to get 500 meg of data on a reasonable kind of prepaid plan. And some of these numbers are pretty big. 17 hours of work in India to get 500 meg of data. They're going to be pretty precious about how they use that data, right? You go and load the BBC homepage and it's like 5 meg these days. But But that's gone and progressed quite a lot. It's been disrupted a lot in the last year. They had the launch of a whole new telco, Geo. They signed up 100 million people in 18 months. That's huge. Imagine starting a new company with the physical infrastructure of a telco and taking on 100 million customers in 18 months. And that's gone and driven the price down phenomenally. But the speed is still very variable around the world. So even when we're on LTE, it's slow. And 60% of the connections around the world are still 2G or edge. You know, when you go to America and you see that little E in the top corner and everything just goes to crap on your phone and doesn't work anymore because it's basically just dial-up sucked through a really tiny straw over 2G. There's still a lot of people that experience that, slow, unreliable, flaky connections. Or even when you're on train. Melbourne doesn't seem to work out how to put internet into train tunnels. It confuses me. I'm originally from Sydney, now in Melbourne, no internet in train tunnels. Doesn't seem that hard. So when we talk about slow and expensive and unreliable connections, well, how much is this really a problem in Australia? If we look at the iOS store, the average size of an app there is 38 meg. Now that's including all of the categories. That includes games and all of their assets. But if we exclude that and we just look at the news category, the average size of an app is still 22 meg. So we've got these really big, heavy experiences to deliver over slow, unreliable, expensive internet connections just to get the news. This is where we start to see this kind of access story come together. Now, the Facebook apps are still pretty big. Messenger is not the smallest of things. So they actually then have this concept of Messenger Lite. Messenger Lite is great because it has a whole bunch less features and stuff that jumps out at you. But it also requires a lot less data. It's even more optimized. And it's designed to work on many different phones in basically any possible network. The particular type of markets they're targeting here is, so as much as I mentioned India, they're still only 35% connected. And then Africa is going to come online next. And there's hundreds of millions of people still left to connect in the world. And they use these types of services. So that's the markets that Facebook goes and targets this app to in the App Store. But you'll also find it in the Australian App Store because they have a comment here of works on all networks, slow and unstable internet connections. And for some reason, it's available in the Australian App Store. It's not available in the US Store, though. The other thing with this is about the quality of the devices in terms of the performance of them. Now, I have a nice, shiny Google Pixel. It's got a great processor and great graphics and all of that. But not everybody has those devices. So Messenger Lite is also focused on less visual interactions that render easier on older devices and a much more distributed set of kind of endpoints. And older versions of Android. Goes all the way back to Gingerbread. So another one is about then generational. Now, I came across this story which was really about sort of getting old and seeing new things in small places. And it's from an author in Portland, Oregon. He was on a flight and he was looking over the seat in front of him and he sees this teen texting away madly. And then the plane takes off and she's still texting. He's like, well, no, that doesn't feel right. He was an idiot. She wasn't texting at all. What she was actually doing was thumbs flying away and she was typing for 4 hours. She was writing on a plane and he spoke to her and said, you know, what were you doing? She was actually writing a novel. And she wrote about 3,000 to 4,000 words on that flight. And for him as an author, he went, well, I can't do that. I didn't write anything. I'm not used to working that way. He sits there and tries to fold out his laptop on the little United seat and whatever and gets annoyed and doesn't work and goes back to his writing environment. But the style of work and what we do is changing. Part of that is these new generations coming through that are used to a different set of devices, some of us going and adopting those devices. And that whole style of work changing through everything that we do. So we've got this kind of generational concept as well. Another one is about this idea of access to a larger audience. So Facebook, billion users. WhatsApp, another billion users. And sure, there's a bit of overlap, but they're both owned by Facebook, but they're still big numbers. WeChat, another billion users in China. Really big markets. This is the Qantas website. I've blanked out all of my frequent flyer numbers and booking references so that nobody can go and do a Troy on me. If there's any left, please let me know. On there's a big blue button, Send on Messenger. So I can use the Qantas website, and one click, I can hit Send on Messenger. And I'm already authenticated because I have an active session with messenger.com, and it can go and send those details through to me. And instantly, it's then available on all of my devices in a familiar interface, and that brand now has a way of, essentially, they're in my contact list. They can send me notifications as my flight changes, as seats change availability, those types of scenarios. They have a way to contact me. So could I go and install the Qantas app? Yes, I've got to install the Qantas app, I've got to log in, I've got to have my PIN number. It works for frequent flyers, but it doesn't necessarily work for people who have a slightly more transient relationship with an airline. I don't have a transient relationship with an airline. I'm not flying for at least 3 hours. So it gives us this kind of market access scenario as well. So this is this kind of push from, I like this term of 1D. So we move from these kind of traditional 2D interfaces of buttons and options everywhere to really thinking about something that's reasonably linear in terms of a conversational interface. So it's text and voice, and we're on a particular path of interacting with something. And one of the other ways that this becomes really interesting is around how it's universally accessible. Because a conversation is really just defined by language, and the world has language, right? So you don't have to go and teach people how to use a device if they can communicate in their existing language. So we get something that's universally accessible to many people via many different form factors, especially when you start to bring in voice. It's also something that can start to cross cultures a little bit. So we have now a standard for representing emotion and objects and events. We actually have this global visual language now that's starting to get popular. And it, kind of like messenger bots, has started in kind of, oh, those silly kids, and is slowly becoming more and more pervasive into even the corporate world. We can go and represent things like fire. We've got personal expression in the sense of diversity and skin tone modifiers and all of that. We've got all these new kind of cultural idioms that are being shared around the world. So the 100 and the double underline is the old Japanese, like, you scored 100 on your test, that's awesome. And that now starts to kind of expand out. And then there's the beloved poop emoji, and plenty of interesting uses of vegetables, of course. Now, emoji started when Google was looking for a way to put better emoticons into Gmail quite a number of years ago, and they found this standard in Japan. It was used on JPhone, and they went, great, it's standardized, it's this thing that we can then go and sort of propose and build into Unicode, and we can build it up from there. But as part of that, they did a little bit of research, and what they found was that people said that in Japan, the experience was that if you didn't have an emoji, then an email felt dry, or it didn't feel personal. And also an emoji was the easiest way to apologize, because you could go and represent emotion. You could represent excitement or surprise or kind of worried or thinking, all these different concepts that are really hard to express in email. So it adds that kind of personal flavor to things. But what I especially love about it is this idea that it's a language that can be remixed. So we have a global standard for a visual language that we can remix. Emoji is built on this concept of zero-width join characters. So you can take a cat, and then, which is like 2 Unicode points, and then a zero-width join, another one, and then that there is called bust as silhouette, is its technical name. And you put these two things together, and the zero-width join says combine them, mash them up, and when that gets rendered on Windows, you get a ninja cat. This is how we can go and make up new emoji. So a couple of years ago, Apple created a new emoji, which was around their anti-bullying campaign. And this was the idea of the speech bubble, and it had an eye in it in terms of, look at what you're sending people and how it affects people. And they were able to create that just by mashing up emoji. And then eventually that gets standardized into Unicode, and off we go, and we get a standardized representation of that. So emoji is now something that's actually built into every keyboard on every major OS for people to have direct input. Anyway, that's lots about that. There's a really cool Fast Company article back from 2014 called The Oral History of the Poop Emoji, which tells you the whole story of how it kind of came to life and Google's experience of bringing it together. So back to this idea of kind of 2D to 1D. One of the other ideas I really like is this idea of then, if we really kind of stretch the dimension concept, this idea of 0D, of tools that, there we go, 0D in terms of ambient computing. So things that don't necessarily have a direct interface but can go and achieve jobs in my life. So for example, monitoring the flight that's coming up and saying, does my favorite seat become available, and go and move it across? Or when I'm heading home, have the house warm or cold or whatever we need to do in Melbourne at any given minute. It changes every 5 minutes. But whatever we need to do to stabilize that out. And that's this kind of idea of ambient computing that as technology people, we think of as background jobs or scheduled tasks, or we can wire up a couple of APIs to each other, but isn't really that pervasive for the general consumer group yet. We can get services like IFT, which put a great user experience over reasonably complex logic, but they're not a broad-scale consumer solution. We can go and have websites that you sign up to. There was one that I used to use where it would take my Strava data and it would automatically send it to Runkeeper, I think I was syncing between. And you set this up, and then a few years later you go, oh, it broke. What was the website again? Or I want to turn it off. Where was the website again? Because this background task has just been running. Or you install an app on your device, and it's like 6 screens later, there's this special app that might do something that eventually gets like shut down by the OS because it's not in use. So I think one of the ways that we can then start to have a more scalable interaction with that and better configuration is we take this conversational, one-dimensional kind of interface and use that as the gateway to this more ambient computing. So being able to have a contact list is a concept that supports a lot more entries than what we typically think of as an app experience. There's a bunch of research that suggests that people think installing and uninstalling an app is quite a kind of a big hurdle, whereas adding and removing a contact is a smaller hurdle for people to consider in terms of building a relationship with something or removing it. Also allows, as we get better at language processing, us to represent more complex logic and have a computer understand how to translate that into computer stuff to go and do versus what a consumer necessarily wants. As we then start to go and look at, well, what are all the different devices that might plug into this? I don't expect my air conditioning manufacturer to build a good experience of natural language processing. That's clearly not going to happen. It's kind of like people still working out how to build decent TVs. But maybe they'll have enough of an interface that I can add them to a group conversation with some other mediator bot that coordinates the different parts of my house and what they should do. So you can kind of mix and match these. There's still all kinds of problems here. Obviously, voice recognition, reasonable. I say, hey, Cortana, and like 5 devices light up. Or more importantly, or more realistically, I actually say, hey, Cortana, hey, Cortana, hey, Cortana. Now just give me the phone. And then we just move on with life. So there's plenty of stuff to solve there. And then as we try to make computers smarter and smarter, especially at natural language, we run into kind of unintended consequences. Does anyone remember Tay? T-A-Y? Yeah, it was a Microsoft bot. It got trained, it learnt really quickly, and it became very racist very quickly, and sent that out to people. And then IBM Watson, a couple of years ago, they found that this idea of, well, IBM Watson doesn't really understand kind of some of the more kind of shorthand phrases and kind of lingo. So they thought, oh, what we'll do is we'll load Urban Dictionary into it, because that'll teach it what OMG stands for. It learned a lot of other things as well. So they've subsequently had to remove that from IBM Watson, and it never remembers ever having learnt that. So it's all well and good doing this kind of 2D to 1D to 0D, but at some point there's also building up. And this is where we've got this 2D to 3D extension now as well. So we're getting a whole new range of devices. There's the HoloLens experience, which there's some around, and I think they've been here at previous DDDs, so people playing with them. All the mixed reality headsets, the Oculus Rifts, all of this type of world. This being able to take mixed reality of putting 3D virtual concepts into a physical world and have them interact with each other. A whole new set of interactions that we're building out there as well. And there's a long way to go in this yet. Obviously, we see all the current devices changing. There's other ones, like this is a thing called Glyph that was released about 2 years ago. And this doesn't actually have a screen in it. So a lot of the devices you'd see currently, they have kind of screens in front of your eyes. This just projects light beams kind of from a little projector straight onto your retinas, and then you can see stuff from that. So one prediction, everyone's got a prediction, but one prediction suggests that by 2025, we'll have that built into glasses. You don't actually need something on the screen as a heads-up display. You can just project it onto people's eyeballs, and then we'll see what happens. I get my first pair of glasses on Monday, but they're not going to be anywhere near that fancy, unfortunately. So as we put all this together, we've kind of got this increasingly complex set of interfaces, lots of opportunity with them, but going from a world of essentially command lines up to GUIs, and now the whole world's just sort of exploded on us. And we're rebuilding command lines in these conversational interfaces with slightly better language processing on them. Turn left, walk over the bridge. And also extending all the way up to that 3D space. Now I put AR at that kind of 2.5D because that's about sort of holding up that 2D thing and putting it over the 3D world, but otherwise quite a spread across all those. Now none of these are the winning interface, none of these are the right one for every scenario, they all have their own context, and we expect to move between them as well. So the next challenge for us then is, well, how do we create this idea of kind of ubiquitous or shared experiences that run across this? Easy, we just upload some state and we push it to the cloud and we're done. If only so simple. Because actually creating a user experience that makes a sensible handoff is going to be a really big challenge that we start to think about as we spread across these environments. We have the kind of simple experience of booking something on Qantas.com and then going to the Qantas mobile app. Now extend that out to every other different type of device in the mix, and it becomes a much more complex activity. There's all sorts of frameworks popping up to go and solve this. Microsoft have their Project Rome. That's R-O-M-E, the city, because all their code names have to be locations. But that Rome is the shared experiences scenario of how do I move between my Xbox, my mobile, and my laptop. Part of this is then enabled by the network. So how do we go and move this information together? The Kindle got released in 2007. Oops. It wasn't anywhere near this sexy. This was not the first Kindle. But what was really cool about the first Kindle was it came with WhisperNet. So WhisperNet was it came with 3G embedded in it. And you didn't sign up for a service. You just turned it on, and it worked. It worked everywhere in America where it was released, kind of like every other product. Works in America. But they were able to basically go and set up a really big deal with AT&T for a big shared data plan and build the cost of the data into the marketplace in terms of into the books. And then as a user, you didn't have to think about going and connecting it to Wi-Fi or whatever in order to get that connectivity onto the device. And it significantly reduced the friction of, I just want to pick up my e-reader and read a book. It went international in 2009, and that became a fundamentally more complex relationship for them with AT&T, as they then had a ginormous global roaming problem. I continued to always set my location as US because I could get the Economist in the US market, but I couldn't get it in Australia. And every time I'd travel, they're like, are you not in the US anymore? I'm like, no, just traveling. And they paid all of the global roaming fees for me. It was great. And then they started to introduce international fees. Damn it. So iPads now, so the Kindle had an embedded SIM. iPads have started to ship with eSIMs and Apple Watches, where they don't actually require a physical SIM in different markets and different devices, but we can actually program the SIM to go and work for whatever carrier or whatever network that it needs to connect to. Then starts to make it a lot easier to change networks as well, because you don't care about the mobile number that one of these is given. And increasingly, we won't give them a mobile number because it makes no sense to waste a 04 something number on an iPad when you don't care about the number. So that will go away, and we dynamically connect to the different carriers. 4G, 5G, they're not available everywhere though. You've still got those basements, you've got the trains, you've got black spots in your house, and as we put more and more data onto them, as people try to work around the NBN, then it's going to get more and more congested. So Wi-Fi is still a valid local experience. One of the things that rolled out earlier this year was the concept of Wi-Fi calling. It was rolled out across most of the networks in Australia, I think, certainly on Telstra, on iOS and Android. And this goes and looks for where you have a Wi-Fi network. It'll actually go to offload the call through that. So you can actually have no 4G connectivity. I can be in the basement of my parents' house, where of course I've installed an access point, and I can still make a phone call, and it works fine, because it just offloads it through the data network. Particularly complex set of challenges to solve about how do you deal with 000 calls and 112 calls and those types of problems. But now we have this kind of offload scenario. So we're starting to get things that are traditionally moving from cellular networks onto Wi-Fi. One of the really interesting standards that's popping up is this concept of Hotspot 2.0. How many people have seen this buried in their Windows 10 config? Very few people willing to admit digging in their settings that far. Hotspot 2.0 starts to bring carrier-type concepts to Wi-Fi. So the idea that I can connect to Wi-Fi at a hotel or in an airport or somewhere like that, and instead of getting assaulted with a sign-up screen with SSL errors and asking for it to enter my credit card or validate my mobile number or something like that, I can essentially get a roaming experience. So I can pick a data plan that I might already have from a home network, or I can pick from, say, the Microsoft Store, and it will then allow me to connect to that network. And the provider of the network can ultimately receive the cash back for that, and it all routes through and it all works. Kind of like when you rock up in a foreign country and global roaming, you don't understand how the billing works, other than expensive, but it works. That's now starting to become increasingly prevalent in network platforms themselves. So all of the Unify kit supports it, most of the Cisco kit supports it, and we're seeing it in the clients. How's it relevant to us? Think about something like any of these types of devices slowly getting into our home. Your Google Homes, your Amazon Echoes, my bathroom scales. They're all reasonably hard to configure to put on the Wi-Fi in some way. They have their own kind of Bluetooth offload experience or something like that. My scales, you have to plug them into a USB cable to a laptop. Otherwise, you'd have to like tap dance left foot 3 times for A, right foot 3 times for B, type the password in or something. What these devices will be able to do increasingly is just rock up in your house, see a Hotspot 2.0 connection, and make their own relationship all the way back to home base. Kind of like the Kindle did over the 3G networks, but over a traditional Wi-Fi network. So it starts to then have this idea that devices can just rock up anywhere, use local networks for better reliability rather than relying on cellular networks, but still get all the routing right. I think that's kind of cool, where devices will just always be connected. You'll buy them, you won't necessarily pay for the data plan directly. We all have black spots in our house though, most people, except for Troy, who spends too much money on Unify equipment in terms of our Wi-Fi. So it's also interesting to see kind of the renaissance of mesh Wi-Fi. So Amplify is a recent solution and plenty of others popping out. For years, kind of mesh networks were this thing that bubbled along and never really worked, and now we're finally finding some good uses for them and they're starting to get reliable. And as we put all these devices on, maybe we'll finally find a use for IPv6 reliably as well. But we can have these devices connected. It doesn't mean that we can necessarily offload everything back to the cloud. Where do we go and run our intelligence, and how do we make our devices smart? If we think about something on a mobile device, even if you've got a connection to the cloud, you don't necessarily have the bandwidth or the quota or the latency or the battery power or something like that to be running a fully connected experience. And one of those scenarios that comes up is in Facebook. You can go and take a video and you can apply filters to it. So they take different artists and they've used these artists to then go and train a series of models in terms of deep neural networks that they can apply over live video that can change the style of your video as a filter. Now, if I want to see that as a real-time preview, I don't want to be sending a live video stream up to Facebook for them to process it and then send it back. The latency is just not going to work, right? So they take these models and they ship them down to your device. They're packaged in the Facebook app. It's one of the reasons it's 700 meg. How's that for 500 meg in India for 17 hours of work? But shipping these models down to the device, and it's kind of regrowth of the idea of the intelligent edge. We've spent years and years offloading everything up to web apps. We're now slowly moving intelligence back to the edge, where we have a reason to do that. One of the other scenarios that they apply this in is Apple, when they go and categorize all the photos on your device. Because they've got their really big privacy push. They don't want to have to upload every photo to the cloud to go and categorize it as like dog, cat, grass, whatever. They push the models down to your device, they apply them locally. When you go and manually add other tags, they use that information to retrain the model, but they can just send some of the, essentially the variables in the model back up to then train it for the greater good for everybody else without having to share your data. So we're in this big kind of collaborative training experiment without anybody actually sharing any data. We're just sharing the inputs and the configurations to the model, or the configuration of the model. Now, lots of different places we can go and apply kind of all sorts of machine learning and image categorization problems, but to pick one, I like this example out of Greece. This is from May 2010, which is right in the middle of the Greek debt crisis. And one of their big problems was around finding where the wealth was. In an 11 million person country, there was something like less than 80,000 people that made over $100,000 a year, supposedly. There were plenty of people who did, but nobody put it on their tax return. And one of the particular things they have in their tax is around pools. If you own a pool, there's a checkbox on your tax return and you owe some more tax because it's a particular measure of some form of wealth they see. But when they went and looked at a particular area, a particularly wealthy area in the northern suburbs of Athens, they found there was 324 residents who checked the box. And then they went and looked at some satellite images and they found 16,974 pools. Didn't quite line up. Now in this scenario here, it says that tax investigators looked at the photos. It doesn't actually say whether they automated it or not. Clearly it's the type of thing that we could automate with some image recognition. Now it's kind of fun. There's increasingly stories of people build like fake roofs or grass over their pools and things like that. So you just have all the fake grass that goes over the top, and it's kind of like the Thunderbird's pool that just disappears, or the reverse of the Thunderbird's pool. When we then think about this type of image categorization, or how do we go and do this, what do we do as developers? Well, we're not going to go and write, well, some people might, but most of us won't go and write image categorization algorithms from scratch. We're usually going to build on the shoulders of giants, people who have really big, well-trained models. We go and call out to something like Azure Cognitive Services, we give it an image, it gives us a bunch of information back. And that's now where we're starting to see this growth of kind of practical machine learning pop up in useful ways. Now, there's all these amazing stories of, we can do predictive analytics on when lifts are going to break and all of that kind of stuff, which is awesome. But I think there's a lot of smaller scenarios where it's a lot easier for us to sometimes integrate this. One scenario is PowerPoint. I took the opportunity to put in a cute, fluffy dog. So why not? When I go and paste this into PowerPoint, it does a couple of things. It actually puts automatic alt text on it for accessibility. So it comes up and says, a brown and white dog looking at the camera. That was what it auto-generated as soon as I pasted that image. That's pretty accurate. It's not always that accurate. I was doing a reasonably different talk about 3 months ago, and I had a photo of a refugee camp in Syria, and the caption it came up with was "Group of people on a beach enjoying themselves." Decided to edit that caption. But what it's also done is down the right-hand side, it has these design ideas. Now, these design ideas, some of them, yeah, sure, they're just templates, different layouts and stuff like that. But what's a little bit subtle in there is that it's also cropping the photo. And it's doing an intelligent crop. Because if you just crop the outside of the photo in, then you're probably going to break the framing. You generally align stuff to the rule of thirds in photography. It's kind of the basics of photography 101. People don't otherwise know how to do it. And if we go and crop this in, we're going to start to crop his ears off. Whereas what we really want to do is maybe trim up more of the neck. And you'll see in the crops on the right-hand side, the center point is actually weighted higher towards the top of the photo. So it's an intelligent crop. These are all the types of things that are actually available to us as developers via fairly simple APIs now of we send an image, it tells us where the recognized object is, where its center point is, and we can then go and do an intelligent crop off the top of that. This is all the subtle little things showing up in these everyday tools that just adds that nice little bit of extra polish to them that I think is quite cool. But of course, just going and wiring a couple of different APIs together and going hope for the best, and not really thinking about it, is also going to cause some problems. Sometimes you get the algorithm wrong, and sometimes even if the algorithm is right, it can have a big social impact. There's a particular one here earlier in the year where Centrelink went off and started their robo-debt process. They ran some fairly simple math, it's not even a fancy algorithm, and just said, you owe us money. Now, when you suddenly start doing that to a large group of people, where even if they do owe you money and you have calculated it correctly, if you've never enforced that before and then you start by sending out threatening letters, funnily enough, it created a bit of a backlash because there's a pretty big social impact for that. So we've still got a lot to learn about how do we actually implement all of this responsibly in our industry. A big part of this is then also how do we trust algorithms to actually know that they're correct and that they're verifiable. And the example I really like here is a simple process of a GPS. When GPSs all came out originally, they'd sit on the dashboard of the car and somebody would have their fancy GPS and it'd say go this way and everybody else in the car would go, no, that thing's stupid, it's going the wrong way. And we still do that half the time. You get in the car, the GPS says turn right and you go, nah, that makes no sense, I'm just going to keep driving straight ahead. And you ignore it. Because you don't necessarily know to trust it. It takes time to build trust in a particular algorithm that you're used to. You get in one person's car and they have Google Maps and maybe you trust it because it's what you use. You get in someone else's car that uses Waze, which is a much more aggressive routing algorithm. It tries to like cut the corner around traffic lights. And a lot of people get in there and go, no, it's not going to work. I really like Waze because it avoids traffic really well. But if you talk to a lot of Uber drivers, they would like to use Waze, but they don't. Because if they use it, then their ratings get a pretty big impact because passengers don't trust it and they blame the driver for taking the wrong way or a more complex way. And their rating drops. So you get in an Uber and you say, hey, can we use Waze? And they're like, yeah, great, awesome, thanks. And then they launch Waze and off you go. And then you get there a lot quicker. Now, part of the reason we don't trust this is we don't necessarily understand what's going on ahead of us and the computer can hide it. It can generate a really good route, but you don't understand why. There's traffic up ahead, there's an accident, something like that. So a lot of this then comes back to user interface again as well, of this gives a little summary of showing, well, there's some traffic here and there's along the route, but then there's different ways of kind of giving the overviews as well. The GPS is one of those scenarios where it can have a reasonably big impact in terms of how long you take to get somewhere or going the right place, but you're still in control because you can go, no, I'm just going to go this way, I'll do what I want. As you start to automate more things, so when we start to move to prescriptive actions in any of our analytics, but in the context of driving, something like self-driving cars, if you're sitting there and the car suddenly takes a different turn to what you're expecting, you're going to feel reasonably unsettled about that experience. We're also going to need to find ways to go and tune this in terms of what somebody wants other than just the quickest way to get somewhere. What's the best way to get somewhere? What's the most scenic way? How do they like driving? Those types of concepts as well. And then there's always kind of the quintessential comparison of what sits on top of a taxi driver's dashboard of the multiple different GPS units and screens all lined up giving different competing views of the world. I'm not sure what happens in this one if you turn into Oracle Road. I think you have to turn the car in, donate it to them, and then walk the rest of the way or something like that. Because I don't know how else you pay the toll. But these kind of side-by-side comparison views really get driven by this as well. So no doubt there's plenty of different places that we can apply all these algorithms, but how do we do that in a way that's sensitive to the people around us? Now, then there's this concept of singularity that comes up as well. So when a computer's better than us at basically everything, Different people have different predictions. Elon Musk predicts that it's about 35 years away, which is really not that far. But he also predicts that he can build the right number of Teslas. So we'll see how that goes and which one wins. But the point is that it's kind of within some kind of practical realm. And no doubt you've all seen plenty of articles about computers taking our jobs and algorithms will replace all of us. Plenty of social contexts where you don't want that, in that as much as I could get a perfectly made coffee from an automated machine, I still kind of like the social process of talking to my barista, especially when I'm working from home, and that's probably my only social interaction for the day, is to leave the house and go talk to another human as they make some coffee. So picking the right kind of scenarios there. But on the topic of work, how do we actually do the compute? How do we make all of this happen? Now, we've had CPUs for a very long time. They work very well. And then we continue to optimize on top of these. So the next scenario that got really popular, or the next solution, was the advent of the GPU. And using GPUs for scenarios, not just in terms of graphics, but in terms of other algorithms that we might run. GPUs are really good at taking a lot of data and running the same operation against it in a single clock cycle. So you can load up a whole bunch of data, and you can say, I want you to do this, and then you can go run on a clock cycle, and it spits out the answer. Whereas in a CPU, we'd more iterate through it. So we get all of that extra efficiency, useful in lots of different algorithms. But we then start to, and this is where then Bitcoin mining started to go, was people were applying GPUs to do it. And if you didn't use GPU, you couldn't keep up. The problem is that they're still a reasonably specialist design. And what if you want to do something else? So Microsoft has spent a lot of money in their research on building out a thing called FPGAs, working with Intel, which is a field programmable gate array. Who's heard of these? Oh, bucket loads of people. Sweet. All right. So field programmable gate array, we can go and program it with something like Verilog, and we can change how the gates go and work. Of course, VS Code supports Verilog because VS Code's awesome and supports everything. In this particular one here, we can map two wires, one coming in, one coming out, one that receives a clock signal. Every time that clock fires, so line 12, it increments a counter. So it's not a for loop or a trigger or something, it just happens whenever that clock happens. And then we map out on line 17, we say this particular bit, attach it to that output. So you have a 50 hertz clock cycle coming in, you kind of slow it down by choosing one of the earlier bits, and at a few hertz, you get a blinking light that comes out the back of that. Basically the extent of every IoT project that anyone ever does, right? You start off with these grand plans, and you've got a weekend and a Raspberry Pi, and then you get a blinking LED, and you're like, well, that's done. Move on. So these then start to become reasonably specialist devices. This is something that they actually use to go and run initially the Bing crawler, which they've shared a whole bunch of stats around how much more efficient that is. Maybe that's why Bing does or doesn't work. But is also something that's now rolling out through all of the Azure infrastructure out there. So as we start to have Azure infrastructure that can use GPUs, when can we start to go and access this? And then we start to get really specific into application-specific integrated circuits. So where do we actually go and make custom silicon to go and do something? So if we look at the HoloLens, they have this concept they talk about of an HPU, which is some nice marketing. They call it a holographic processing unit, but is basically an application-specific integrated circuit, which is that all of the gesture recognition of when you do the bloom and the air tap and all those types of concepts, they're actually running in hardware to do all of that recognition in order to be able to maintain the frame rate. So we get a great experience in terms of performance. The downside currently is configurability of that. That's why you can't go and teach it new gestures, because it's pre-programmed into the silicon. In the next version of HoloLens, they talk about adding a machine learning coprocessor, which is another essentially application-specific integrated circuit, which is going to be really good at going and training neural nets. And then the main scenario, or popular scenario to date for ASICs that I mentioned, was around Bitcoin mining as well. You essentially just cannot compete in any form of Bitcoin mining without building a ginormous farm of application-specific integrated circuits of Bitcoin mining tools, filling a warehouse with them, and then finding a cheap power source somewhere. So plenty of lovely photos of that. What I really liked, though, was people who go and find power in places. And there's this one guy who got his Tesla, and Tesla has free power at all the charge points. So he built a Bitcoin mining rig in his boot. Then you can just go along, plug into the supercharge point, and we're sorted. Off we go, right? It's a lovely photo, but then, of course, the internet's gone and torn it apart and said, no, that's just a motherboard with some GPUs on it. Sorry. So it may or may not actually be accurate. It's certainly a lot simpler than quite like this one, which was three JavaScript developers adding two numbers together in terms of every different framework you could possibly use, but a larger version of the start of what is quantum computing. So this photo here is actually from UNSW. They have the coldest place on Earth. It's not Melbourne, it's actually in UNSW. And they're starting to actually get stable qubits. So quantum bits that they can run quantum entanglement across, and that they can actually run quantum computing across it at very small numbers of qubits, but it is starting to work. What's going to be really interesting about quantum computing is when it makes a whole bunch of operations that have traditionally had a variable performance for us get a consistent performance. So something like taking a list of things and sorting that. We talk about all forms, different forms of ON kind of notation and performance of different algorithms, and we have all these different sort algorithms. Well, in a quantum computer, we can put the list in and we can simultaneously evaluate every possible scenario and instantly get the sorted list that comes out of it as the next step. So it fundamentally starts to change what we're able to do with these algorithms, especially around, undermines a lot of what we do in encryption and hashing. Factoring numbers becomes a lot easier and is going to be a really interesting impact on what we do. Azure recently announced that they're, everybody's competing for all the marketing at the moment, but Microsoft talked about they're getting close to having a commercially available quantum computer, and they're going to be releasing their quantum toolkit later this year that you can download. It runs in Visual Studio, it has a programming language that you can go and write in. It's an evolved version of what they started as Liquid, which was something they built on top of F#, but the syntax didn't quite work, so they've come up with new syntax, and you'll actually be able to go and run that. Now, locally, you'll be able to actually simulate up to 32 qubits. You need 32 gigs of RAM to do that, though. And for every additional qubit that you add, you need to double the amount of RAM that you have, because it doubles the probabilities of, or number of scenarios that you need to consider. The Azure version that they'll offer, in terms of a classical computer emulating quantum computing, will be able to simulate up to 40 qubits, which adds up to something like 8 terabytes of RAM. So hence run that in the cloud. Nobody's going to run that locally. It's like trying to run Azure Stack. One of the really good explainers, though, that's just a fun video to watch as well, is one which has Paul Rudd and Stephen Hawking in it. And it starts off by, there's an email that, so Paul Rudd is Ant-Man, starts off with an email that comes from 700 years in the future from Keanu Reeves, who of course has not aged at all, because Keanu Reeves, inviting Paul Rudd to attend an event, and says you need to get along to this event at Caltech and you need to keynote it. And he phones up and says, I'm meant to keynote your event. And they say, no, we've got Stephen Hawking. And then he has to, in order to save the universe in the future, he has to challenge Stephen Hawking to a game of quantum chess. This video goes for about 14 minutes, but it actually explains some really great quantum concepts in there. And it introduces the new move of Schrodinger's king, which is when the king is in two places simultaneously. So you're able to move ahead, and you have different pieces in different places, and until the game causes the exact position to have to be evaluated, it can be in all of those places simultaneously. So it becomes a game of probability of does the wave function collapse in your favor as you're playing chess, because chess wasn't complicated enough in the first place. Of course, there was a whole bunch of people like us that got a little bit too excited about this and have subsequently gone off and started building this. So it's actually also up on Steam Early Access. You can go and download Quantum Chess. So it's really probability chess, but introduces in a reasonably constrained kind of number of positions in terms of what's on the chessboard, some really complex concepts that are fun to play with. But highly recommend search Quantum Chess, Paul Rudd, Stephen Hawking, and check that out. So what have we gone through there? Starting to talk about interface in terms of this scaling from we've done a lot of work around 2D as an industry recently, down to this idea of 1D or this conversational flow really coming through, and then the growth of ambient computing and it being the gateway to that, and then also the scale up to 3D. The complexity of how do we put shared experiences across all of that is going to be a really big user experience challenge, but is also going to create some interesting kind of state handoff architecture problems as well. How do we go and connect all of these devices, I think, is going to fundamentally change. How does that affect us as developers? Obviously, it depends on all the different areas you work in, but I think the idea of having devices that are constantly connected via dynamic networks is going to make for some really interesting scenarios of just being able to buy stuff, put it in your house, turn it on, and discovers what's around it. It's also fundamentally changing some of the kind of economics around the carrier model. We're seeing this growth of, as much as we've spent years and years building the intelligence and all the compute back into kind of centralized locations in terms of the intelligent cloud. Now we're seeing the growth of the edge again, which is really something that builds on top of IoT. So where IoT is in a lot of ways kind of simple sensors for where a lot of people think about it. How do I take a sensor and connect it? Or how do we put the smarts directly onto the edge as we get computers that are able to run fully capable operating systems there, rather than unpatched versions of Java from 10 years ago running a new VCR. And then scaling that intelligence out even into mobile phones in different ways as well. So the idea of going and actually distributing machine learning models with applications, I just think is going to be an interesting packaging problem and really cool. And then we're seeing this fundamental change in compute. And I haven't even mentioned things like containers as different forms of virtualization and hosting and serverless and all of that. But the idea of where do we get our compute from and where can we execute it and how does it work, starting to really fundamentally change. So a reasonably jointed tour through all of those things, hopefully. That's my view of how they might connect, but really interested, as I said before, on how do you see those things connecting and what are the gaps you see in that. They're all practical things that you should be able to really go and start playing with today. Even the quantum computing, you'll be able to download the quantum toolkit, or now you can download things like QCL, which is another language, and you can start executing it locally and playing with that. So they're all types of things that we can start to learn about now and integrate into what we do. So based on that, lots of sessions today that will go into a lot more detail, and thank you very much for having me.